S3 students, welcome back to physics lesson with me, Pratama. And today we are going to talk about radio. In the modern era, radio waves control everything, from the tunes in your car driving down the road to the police radio in the car that's pulling you over for not signaling your turn. These waves are undetectable and invisible to the human senses, but they make up the foundations of modern connected technology. While the roots of modern connected technologies may be radio waves, the underlying tech that makes the radio waves possible is a rather simple concept to understand. Any person can make a simple radio in their home for a few bucks, which is part of the reason this foundational communication technology dates back to 1895. As a demonstrable introduction to understanding what radio is, we'll engage in a simple explanations of how you might make one. All you need is a battery, a coin, and an AM radio. Tune the radio to a static channel and start tapping the coin on the two terminals of the battery. You'll start hearing the tapping through the AM radio. By doing this, you'll have made a crude radio transmitter. These radio transmitters are capable of communicating in Morse code or random taps over just a few inches though. What you are doing in this process is exciting electrons on the transmitter side, the battery and the coin, which then is received as a signal on the receiving side, the AM radio, and turned back into an audio output. What you are doing is completing a circuit between the battery terminals, which creates an electromagnetic force which can be detected by the receiver in the AM radio. In order to understand radios more detailed than what we have just discussed, we need to take a little trip through history. Back in the early days of the radio technology, in the whereabouts of the early 1900s, radio transmitters were referred to as spark coils. This was due to the fact that they created a large high voltage sparks, upwards of 20 kilovolts, to send out a signal. This issue was the message was sent out on all frequencies in the radio spectrum, meaning that there was essentially only one localized channel. This was fine when back in the days where no one was really using radio. But nowadays, if you do something like this, and you'll get fined or sent to prison maybe. These early spark cells were essentially doing the same thing as the coin and the battery experiment, except at much larger scale, meaning that they had a lot higher range. Riding the magic school bus back to the modern era, in today's radios, we use sine waves to transmit all sorts of information from audio to video to raw data. By utilizing sine waves for transmission, radios and devices can distinguish different channels based on their frequency, or the number of cycles in the sine wave per second. This allows tens to hundreds to thousands of channels on modern radios, all in the same space without too much interference from each other. Every single radio has two parts, a transmitter and a receiver. The transmitter is responsible for taking a string of data and encoding it to a sine wave. After that encoding happens, it can also be amplified and sent out across the air. The receiver rather expectedly receives the radio waves and decodes the message and encodes it into the sine wave. Each side of this system uses antennas to radiate or receive the signal. Relating radios back to your life a little bit, chances are you are watching this video as a result of a transmission of radio waves. Cell phones use radio in their most basic form. They contain both transmitter and receiver and can run both at the same time. In general, phones use frequency modulations or FM in a frequency of range 800 MHz in any one of 1600 individual frequency. All of this number and data probably is meaningless to you right now, but hang on. As we go deeper back to our simple battery demonstrations, we can recall that an electromagnetic force was created when the battery circuit was completed. Other radios built out of this idea by creating rapidly changing electric currents on the transmitter side. One of the best way of doing this is by utilizing sine wave, as we have discussed. To create a sine wave radio, use capacitors and inductors to vary the current and voltage in a controlled means. Transistors are used to amplify the signal so that it has further range. The problem, though, is, as you might pick up, is that sine waves don't natively carry any information. They provide a foundation for transmitting information, like the Oreo cookie in the transmitter for that delicious feeling, or like crackers are the foundations to that dry-aged Gouda. You get the point. In order to get sine waves to actually carry information, you need to modulate it. You can do this in 3 ways: pulse modulation, amplitude modulation, and also frequency modulation. Pulse modulations means that you turn the sine wave on and off, just like the IT guy suggested. Doing this allows you to easily send the Morse code, but that's just about it. Pulse modulation is barely used except to control the clocks across the US. The simplicity of pulse modulation also allows one pulse modulator to cover massive areas, like the entire United States. Amplitude modulation, on the other hand, is what is utilized by AM radio stations and TV signals to encode their data. In this format, the amplitude or peak-to-peak voltage of the wave is changed. You can imagine this as the wave from a person's voice being combined with a sine wave to create a new rather complex sine wave with the same frequency but with a lot more data inside. Finally, we have frequency modulations, otherwise known as FM. It's used for FM radio and tons of other wireless technology. In this encoding technique, the sine wave frequency changes slightly based on the signal. This means that the distance between the peaks of the waves is varied on the data that is trying to be transmitted. Bringing all of these techniques back in the real world, we can begin to understand them a little further. Okay guys, that's it for today. I do hope you understand about all the information that I explained to you just now, and we will talk more about this in our WhatsApp and also Zoom session. Thank you very much for your attention. See you again and bye-bye.